Hi everyone, this is Santi, faculty from Department of Mathematics and Statistics, Bhavans Vivekananda College of Science, Humanities and Commerce. This video lecture is in linear algebra and it is lesson 2. It is a continuation of lesson 1 which also has prerequisites to learn linear algebra for undergraduate courses. In this lesson 2, I am going to explain the following three concepts. First one, echelon form of a matrix. Second one, reducing a given matrix to echelon form. And the third one, solving system of linear equations using matrix method with echelon forms. Echelon form. So before looking at echelon form, let us discuss about some important terminology regarding the echelon form. So I will take an example. One matrix I will be taking, that is 2, 1, 0, 2, 2, and then second row 0, 3, 0, 4, 5, and the third row 0, 0, 0, 0, 0, and the fourth row 8, 0, 0, 0, 0. Now let me explain about points regarding this matrix. So I have here 4 rows. This I will call row 1, and then row 2, and then row 3 and row 4. 4 rows I have. Now I have the first term, that is 0 row. So what is a 0 row? A row with all 0 entries. So we can quickly see here row 3 is a 0 row. 0 row. Then the second one I have a non-zero row. So what is a non-zero row? A row with at least one non-zero entry. So what do you mean by that? Minimum one element should be non-zero. That means that there shouldn't be like all elements should not be zeros. So you can see here R3 is a 0 row and R1 it has some non-zero entries, and similarly R2 also has 3 non-zero entries and R4 has 1 non-zero entry. So I can say here R1, R2, R4, R1, R2, R4 are non-zero rows. Then what is the next term I'm going to use here is leading entry. So, leading entry is the first non-zero element or entry, you can say, in a row. So if I take the first row 1, so what is the first non-zero entry in this? This is first row, first column element 2. So 1 is not a leading entry because it is not the first non-zero element. 2 is already first non-zero element. That's it. So this 1 and 2, 2, these are not non-zero entries. So these are not leading entries. Now when you take the second row, 3 is the first non-zero entry. So 3 is leading entry here. Then when you take row 3, it is a 0 row. There is no non-zero element. So it does not have any leading entries. When you take the fourth row, it has a leading entry, that is 8. So this is regarding leading entries. Now let us see, when do we call a matrix to be in echelon form? So let us see the definition of echelon form. So for this I will take here, before defining, or I can say first, let me start with the definition. A rectangular or a square matrix is said to be in echelon form if it satisfies the following conditions. I have some conditions 1, 2, 3 to explain those conditions. Let me take two examples of matrices here. When I am taking A as 0, minus 1, 0, 0, 7, 0, 0, 0. Randomly I am taking matrices. It need not be, or it can be a rectangular matrix or a square matrix. So 0, 0, 0, 3. Then I'll take another matrix where I have 5, 0, 0, 9, 0. These are zeros. Then 0, 0, 2, 1 zeros, 0, 0, 0, 0 minus 5, and 0, 0, 0, 0, 0. So I have taken two matrices. Now let me explain here what are the conditions. So rectangular or square matrix is said to be in echelon form if it satisfies the following conditions. The first one is if there is any zero row, then it must appear after all the non-zero rows. So let me see matrix A. Is there any zero row? Yes. Second row is a zero row. Then what is the first condition? If there is any zero row, then it must appear after all the non-zero rows. That means it should be, if it is there, it should be the last row. But here it is in the second row, whereas there are four rows. So this A is not satisfying the first condition. When I take B, matrix B, I have a zero row here, so which is row 4, and it is appearing after R1, R2, R3. So my first condition for echelon form is satisfied by matrix B but not by matrix A. Now let me see the second point in this. Each leading entry of a row must be in a column to the right side of the leading entry in its previous row. So this point is little tricky. Each leading entry of a row, so let me take, suppose for example, matrix A. So let me first, to apply the second condition, let us round the leading entries. In matrix A, I have first row minus 1 as leading entry. Second row, there is no leading entry. Third row, I have 2. And the fourth row, I have 3 as leading entry. Whereas in matrix B, I have first row 5 as leading entry. And in the second row, 2 as leading entry. And in the third row, I have minus 5 as leading entry. Now let us look at this point 2, which is here given here. Each leading entry of a row. So if I take first row, leading entry is minus 1, then it must be in a column to the right side of the leading entry in its previous row. So if I take first row, there is no previous row for that. I don't need to check about the leading entries of the first row for condition 2. Now let me see the second row. There is no leading entry. Then let me take here row 3. Where is the leading entry? Here this is 2. Then let us look at the point 2 again. Each leading entry of a row. So leading entry of a row must be in a column to the right side of the leading entry in the previous row. What is its previous row having leading entry is row 1, which has minus 1. Then according to this condition, this 2 must be in a column to the right of minus 1. That means this 2 must be either in the third column or fourth column or fifth column, but I have it in the first column to the left side of minus 1. So this matrix A is not satisfying. This row is not satisfying condition 2. Then let me check matrix B. First row I don't need to check. Then second row, where do I have leading entry? Second row, third column. Then what is its previous leading entry? First row, first column. So to the previous 5, this 2 is towards right side. So yes, so this second row is satisfied. Let me look at the next leading entry, that is in row 3. I have minus 5. So what are its previous leading entries? 2 and 5. So to the previous ones, this minus 5 is towards right side. That means all the leading entries in matrix B are satisfying condition 2, whereas in matrix A, the second row leading entry 2 is not towards right side of minus 1. That means this A is not satisfying the second conditions. Or you can say in simple that all the leading entries row wise they should move towards right side. They shouldn't be to the left side of the previous leading entries. That is point 2. Now let us come for point 3. What is point 3? All entries in a column below a leading entry must be zeros. So all entries in a column below a leading entry, that means leading entry where it is there, locate that column. So let me take matrix A. What is the first leading entry? Minus 1. Then what are the elements in that column? 0, 0, 0. Yes, they must be zeros, following ones. Then what is the leading entry in the second row? This is 2. In this column, after 2, in the next rows, they should be zeros. Then what is the next leading entry here? 3, and this is a column, but there are no elements after 3 here in the next rows. So this matrix A satisfies condition 3. Though it was not satisfying condition 2, it is satisfying condition 3. Now let us see matrix B. So first leading entry is 5. In this column, all the entries following this should be zeros. Yes, there are zeros. Then suppose. Then the next leading entry is 2. It is in the third column. Then following 2, the other 2 entries, zeros. Yes. Then next leading entry is minus 5. Then it is in this column. Then what are the elements following minus 5 in that column is 0. Yes, there are zeros. Suppose I have here, for a chance, if I have here 1, it doesn't matter because after minus 5 in the next rows there should be zeros, not before minus 5. Following minus 5 should be zeros. If they are not zeros, then it is not in echelon form. So finally, this matrix B is satisfying all the 3 conditions. Let us once again go through these 3 conditions. The first condition, if there is any 0 row, then it must appear after all the non-zero rows. So I'll quickly go through B matrix. There is a 0 row, that is row 4, which is coming after all the non-zero rows. Whereas in matrix A, there is a 0 row which is coming in the second row, which is not coming after all the non-zero rows. So the first point is not satisfied by A, but it is satisfied by matrix B. Now, second point, each leading entry of a row must be in a column to the right side of the leading entry in its previous row. So that I have observed here in matrix A, minus 1 is the leading entry. We don't need to check in the first row. Second row, no leading entry. Third row, I have here a leading entry, but this is towards the left of the previous leading entry. So this is not satisfying condition 2. Whereas B matrix satisfying all the leading entries, they are moving towards right side. So it is satisfied. Then condition 3, all entries in a column below a leading entry must be zeros. So below a leading entry, 5 is leading entry, others are zeros. 2 is leading entry, after that they are zeros. Minus 5 is leading entry, after that zeros. Right? Even A is also satisfying condition 3. 2 is leading entry, after that 0. And this element minus 1 is leading entry, all are zeros. And next leading entry is a 3. There are no elements after that, no keys. So if any matrix, if it satisfies all these 3 conditions, then it is said to be in echelon form. So here we have matrix B is in echelon form. Now let us see some more terminology, or I can say some words what we use when you solve the system of equations. So that is the next one I have here is a pivot position. So what is a pivot position? The position of a leading entry in an echelon form. So let us quickly take one example. Right. So this is an echelon form. I have a leading entry here, I have a leading entry here, I have a leading entry here. Then I have, now let me see, the pivot position, the position of a leading entry. Suppose the first row I have a leading entry 5, it is in first row, first column. So first row, first column position is pivot position. Similarly, second row, third column position is pivot position, and third row, fourth column position is a pivot position. Now what is the next one is pivot elements. So this is nothing but the elements which are there in the pivot positions are called pivot elements. The elements, or you can say the entries in the pivot positions. So in this matrix I have 5, 6 and -5 are the entries which I call them as pivot elements. And then I have another one is a pivot column. So a column with a pivot element or pivot entry, I can say entry or position, anything. So when I look at here, first column C1, it has a leading. So I have here, now let me take C1, C2, C3, C4 columns. So if I take column 1, which has a pivot position or pivot element, so I call this as a pivot column. Second column, it does not have a pivot element or pivot position, so it is not a pivot column. Third column has a pivot element or entry here, so this is a pivot column. Fourth column is also a pivot column. So in this matrix I have C1, C3, C4 or pivot columns. So we have learned now pivot position, pivot elements and pivot columns. Now let us see when any given matrix how to reduce it to an echelon form. So let me take a matrix A is equal to, so I'm taking a matrix 3, 2, 4, 8, 9, 6, 12, 24 and then 2, 4, 6 and 8, -3, -4, -6, -8. So I have to reduce it to echelon form, and we have to use only row transformations to reduce to an echelon form. So no column transformations, because we are using this echelon form to solve system of equations. So each equation is represented by a row in the matrix. So we should not disturb that alignment. Only row transformations are to be used to reduce it to echelon form. So what is the first point or anything, the major thing when we are observing an echelon form is pivot elements, or you can say leading entries or anything. So you have to obtain first leading entries to start with. So always start with, this is row 1, row 2, row 3 and row 4. So, and see to it that the first row has the first element a non-zero element. So I have here, it's given the first row, so mark it. There is no condition on that. The first row, first element, if it is a non-zero element in your given matrix, round it, it is a leading entry, or you can call it as a pivot element. Now, what is the first point in an echelon form? So, I say not the first point, the last point, the third point. All entries in a column below a leading entry must be zeros. So, that we have to follow first. Using this 3, we will make in this first column all the entries, that is these 9, 2 and minus 3. First column entries zeros. So for that, what do? Is we'll apply row operations. So I want to change second row R2. So how can I make 9 0? So R2 minus 3 times R1. So 9 minus 3 times 3, 9 will give you 0. This should be this we should make it 0. Then similarly R3. I want to make this 2 0 using this 3. So multiply third row with 3, 3R3 minus 2R1. And then fourth row R4. What am I going to change? So I want to get 0. Minus 3 and plus 3. If you add, you will get 0. So we will make R4 plus R1. See here, I am using row 1 to make all the entries in the first column of other rows zeros. So then I should not change anything in row 1. Whichever the row we are using here to transform the other rows, we should not use them in the same step. We can use them in the next step. So I'm changing R2, I'm changing R3, I'm changing R4, but I'm not changing simultaneously R1 because I'm using R1 to transform all the remaining rows. So if I apply these operations, then what am I going to get here? So I have the first row unchanged 4, 8, then 9 minus 9, 0, R2 minus 3, R1, 6 minus 3 2s are 6, 0, and then 12 minus 4 3 is 12, 0, and then 24 minus 8 3 is 24, 0, then next one 3R3 minus 2R1, so 3 times 2, so this is 2 times 3, 0, and then 3 times, if 3 4 is 12 minus 4, 8, and then 18 minus 8, 10, and then 24 minus 16, 8, whereas the last one is R4 plus R1, so minus 3, 3 is 0, and then minus 4 plus 2 is minus 2, and then minus 6 plus 4 is minus 2, and then minus 8 plus 8 is 0. So I have transformed A to this. Let us again mark the leading entries. So the first row leading entry is 3, and in this column all the other entries are zeros. So my work with this element, first pivot element, is over. Now I have to identify the leading entries or pivot elements in the next row. Second row, it is a 0 row. And what is that? We have one point in the echelon form definition that if any 0 row is there, that must appear after all the non-zero rows. So what am I going to do is, I will interchange the rows. I want to send this row 2 to the last, so I am changing R2 to R4. Then this matrix is transformed to 3, 2, 4, 8, 0, 8, 10, 8. I'm sorry, this is R4 has to come here. 0 minus 2, minus 2, 0. And the third row 0, 8, 10, 8, 0, 0, 0, 0. We can interchange in any way. I just interchanged R2 and R4. So let us again mark now. First row, this is a pivot position. Then second row I have pivot position minus 2. Then what is my next step? In this column I have to make the remaining entries zeros. So what do I have here? This third row, second column element 8, I have to make 0 using the pivot entry in its previous row, right? So I'm going to change R3. What am I doing R3? R3 plus, so if I multiply 4 times R2, so this becomes 0, then matrix A is transformed to, I have 3, 2, 4, 8. I'm changing, making the changes for R3, so there is no change in the other rows. So I have here 0, so 8, then minus 8, 0, then 10 minus 8, 2, and then 8 minus 0, anything 0, and the last one is 0, 0, 0, 0. So we have done some more transformations. Now I got, again let us mark the leading entries or pivot elements. So first row pivot element, second row pivot element I have, so that's already over. Then the third row, this is the pivot element. Then my aim is to, in this column after 2, all others should be zeros. It's already 0 in this column. I have the other one is 0. And in the fourth row, there is no pivot element. There is no leading entry. It is a 0 row. So let me check all the points which have to be satisfied for the matrix A to be in echelon form. Is the first one, any 0 row, if it is there, then it must appear in after all the non-zero rows. So in the last R4 is a 0 row, and the next one is the all the pivot positions should be to the right side of the column containing the previous pivot positions. So 3 and minus 2 is towards the right side of 3, and 2 is towards the right side of minus 2 and 3. That's all. These are the 3 pivot positions. And the last point is the entries following a leading entry in a column should be zeros. So first column I have 3 and following elements are zeros. And here I have minus 2, and in this column all the other elements or entries are zeros. And here I have, and in this column the following entries after 2 are zeros. So this one is reduced to echelon form. So matrix A is reduced to an echelon form. Now let us see one more example. So I'm taking the second example. So matrix A is equal to 2, 4, 5, 4, 1, 2, 4, 5 and 4, 5, 4, 2. So let us do it quickly. First row, I have the first non-zero element, I marked it as 2. And then using this 2, in which column it is? In the first column, I have to make the following entries in this column zeros. So I'm going to do the changes to row 2 and also to row 3. So row 2, I have to 1 here, and then I have to make it 0. So multiply 2R1 minus, 2R2 minus R1. That is a change transformation for row 2. And for R3, 4, and multiply the first row with 2 and then subtract from it. So R3 minus 2R1. So if I do these transformations, this is reduced to 2, 4, 5, 4, and then 2 times R2 elements. So this is 0. 2 to 4 minus 4, then it is 0. 2 4 is 8, minus 5 is 3. 2 5 is 10, minus 4 is 6. And to the third row, I am doing R3 minus 2R1. So 4 minus 2 is 4, 0. And then 5 minus 8 is minus 3. And then 4 minus 10 is minus 6. And then 2 minus 8 is again minus 6. So every time you transform it and then mark the pivot elements. So first row is over. Then in the second row, where is the pivot element? So after marking in the row, then you have to look at the column. So in this column, this is in the second column. We have to make other entries 0. Other entries, not all the entries. No need to do this 5 as 0. Minus 6, which is following. So we have to make this 6 as minus 6 as 0. So for this, what is the transformation we are going to apply? We are changing R3. Then, and here what do we observe? Yeah, let us continue. We'll go for the next one. R3. So I have to make this as zeros. So I have here R3 plus 2 times R2. So what do I get? This is transformed to 2, 4, 5 and 4, and then 0, 0, 3 and 6, 0, minus 3, 0, and then minus 6 plus 12, which gives me 6 again. Now I have here, and then I have here a pivot position in the second row. My work is done in this column. Now I'll go to the third row. There is here I have in the a pivot position, but this is towards to the left of the second row pivot entry. So I want to make it according to the conditions if possible. I can do some transformation. I can interchange row 2 and row 3. So what am I doing is row 2 I am interchanging with row 3. Then what is it transformed to? 2, 4, 5, 4, and then 0, minus 3, 0, 6, 0, 0, 3, 6. Because we should not have pivot entries towards the left side of the previous row pivot entries. So now let me check first row. This is pivot entry, and the second row, this is pivot entry, and the third row, this is pivot entry. And you can even observe the first pivot entry is 2 and it's in its column. All others are zeros following that element. And the second pivot entry in the second row is minus 3, and in the column elements which are following minus 3 in the column are zeros. And the third row pivot entry is 3. There are no following elements in that column. So now this B is in also this matrix, whether it is A or B, is in echelon form. Now let us see the third point that I am going to explain in this lesson, that is solving a system of linear equations using echelon form. So for this, let us consider a system. So I am taking a system of equations 3x1 plus 2x2 plus 4x3 is equal to 8, 2x1 plus 4x2 plus 6x3 is equal to 8, and 9x1 plus 6x2 plus 12x3 is equal to 24. So if I convert this into matrix equation, that is Ax is equal to B, and write the X is equal to D, let us say. So, and I'll take the augmented matrix AD. So what is this augmented matrix? It is nothing but taking the coefficients of x1, x2, x3, the variables in this system. First row coefficients 3, 2, 4, and second row coefficients 2, 4, 6, and the third row coefficients 9, 6, 12, and D is nothing but the right hand side values of the system of equations 8, 8, 24. So this Earlier, the same matrix in this lesson only, we reduced it to echelon form, or let us do it once again. So let me do convert this matrix. So I have here the first row, first element is 3. This is my leading entry or pivot element. Using this, I have to make the other entries in this column 2 and 9 as zeros. So quickly I'll do R2. I have to transform. So R2 I have to make here this first entry in second row 0. So multiply this R2 with 3 and then subtract uh, from it, subtract 2 times R1. Then this will become 0. And then the third row, this 9, third row first column entry should be zeros. This can be 0. So R3, if you multiply the first row, first element 3 with the 3 and then subtract R3. So R3 I have R3 minus 3R1. If I apply these two transformations, so this AD is transformed to, so this is 3, 2, 4, 8. And then this is 0 because 3 times 2 6 minus 2 times 3 6 minus 6 0, and then 3 times 4 12, and then minus 4 is 8, and then 3 6 18 minus 8 is 10, and then 3 8 24 minus 16 is 8 I have, and then R3 minus 3R1 9 minus 9 0, 6 minus 6 0, 12 minus 12 0, and then 24 minus 8 into 3 24 0. So now let me see whether what are the leading entries or pivot elements in this first row, first column. This is 3, and in this column I made these two zeros, right? Then in the second row, what is the pivot element? That is 8. Then in this column, what are the elements in the second column following 8 0? It is already 0, so we don't need to do anything. And the third row is entire zeros, so this is completed. So what did we do? The given system of equations, we have written the augmented matrix and we reduced it to echelon form. So before talking about now the solution of the system, let us write some terms regarding this echelon form, some more terms. Now here you have how many columns? 3 columns, C1, C2, C3. Till here only C4 is there, but this considers the right hand side of the system. So let us take only these 3 columns. Now I have, what are the pivot columns? We had the definition of pivot column, that is a column which has a pivot element is called a pivot column. So the first column, if you take, do you have pivot element? Yes. So this is a pivot column. And the second column, C2, also has a pivot entry here, 8. So this is also a pivot column. Whereas C3, it does not have any pivot position in this column. So C3 is not a pivot column. So pivot columns I have C1, comma C2. And then if these are pivot columns, I am giving another word here, basic variables. In this system of equations, how many variables you have? X1, X2, X3. Now when I come for this echelon form, so this echelon form also represents the system of equations. So since I have here C1, C2 columns as pivot columns, I will say the variables x1, x2 are basic variables. So if whatever the column is a pivot column, then the variable corresponding to that column, we call it as a basic variable. Then what about the column C3 and its related variable x3? That I call it as a free variable. So here I have x3 as free variable. Now how do these basic variables and free variables decide the system, solutions of the system? Right. Now let us consider this echelon form. Now let us rewrite the equations again from the echelon form. So So if I rewrite the equations from the echelon form, I'll get 3x1 plus 2x2 plus 4x3 is equal to 8. And then 8x2 plus 10x3 is equal to 8. So how does this echelon form help us? It helps us to simplify the equations. Right. So I have here simplified equations now. But how do I arrive at a solution? I have 3 variables. I have only 2 equations. Then what do I do is, there is a free variable x3. Choose this free variable as free. That means I'll take let x3 is equal to k, some constant. Then I give this equation 1 and equation 2. Then 2 implies I have 8x2 is equal to 8 minus 10x3, or I can say it is 8 minus 10k, which implies I have x2 is equal to 1 minus, so I have 5 by 4k. So if I choose x3 as k, then x2 value I got it in terms of k. Now what is other variable remaining here? x1. So substitute these x3 and x2 values in equation 1. Substitute in equation 1. Then I get 3x1 plus 2 into 1 minus 5 by 4k plus 4k is equal to 8. I'm taking LCM. Then I will be getting here. So this, if you expand this 3x1 first, plus 2 minus 5 by 2k plus 4k is equal to 8. And then I have 3x1 is equal to 8 minus, so I have here even I can say 8 minus, right, so let me write 2 plus 5 by 2k minus, so 2 minus and then 4k, so which will give me 8 minus 2 6, and then plus 5 by 2k minus 4k, and then this, if I take LCM, 12 plus 5k minus 8k by 2, this is, so this will give me, so 3x1 is equal to 12 by 2. So I have 12 minus 3k by 2, or I can say x1 is equal to, so this is 12 by 6 minus 3k by 2 into 3. So this is 2 minus k by 2. So this is x1 value. So what did you observe here? Here we assumed x3, which is a free variable, as k. Then we got x2 value as 1 minus 5 by 4k and x1 value as 2 minus 1 by 2k. So how many solutions this will have? When I assume x3 is equal to k, I can give any value. Suppose k is equal to 1. Then x3 is 1 and x2 is equal to 1 minus 5 by 4 and x1 is equal to 2 minus 1 by 2. So which will give me the other values, minus 1 by 4 and then 3 by 2. Similarly, if I take k is equal to 2, then I'll get some other set of values, x3 and x3 is 2 and x2 and x1 and so on. What does it mean? This system has infinite solutions. So this is why, because this system, so we are not giving here exactly what are the solutions, we are only giving a formula to find the infinite solutions, that is x3 is k and x2 is 1 minus 5 by 4k, and x1 is 2 minus 1 by 2k. So this even we can observe it using the basic variables and free variables. You can observe here this system has one free variable. So this you can note down here, this system, it has the free variable. Let us discuss and conclude about this by observing one more problem also. So let me take another problem, second problem, another matrix. So I'm considering another system, that is 2x1 plus 4x2 plus 5x3 is equal to 4. x1 plus 2x2 plus 4x3 is equal to 5. 4x1 plus 5x2 plus 4x3 is equal to 2. Then the augmented matrix AD, this is D, which is given by 2, 4, 5, 4, 0, 1, 2, 4, 5, and then 4, 5, 5, 2. The same matrix earlier when I was giving you examples of reducing to echelon form, the same matrix we got, and we got its echelon form as 2, 4, 5, 4, 0, 3, minus 3, minus 6, and 0, 0, 3, 6. This already I obtained it in the previous echelon form. Then let us see what are the pivot positions. Here, and there is a pivot position here. There is also a pivot position here. Then, so this is first column C1, and this is second column, third column in this. And in this I have, so let me see what are the pivot columns. Pivot columns are, then C1 has a pivot position, so C1 is a pivot column. C2 has a pivot position, C2 is a pivot column. C3 has a pivot position, so C3 is also a pivot column. Then what are the basic variables in this? So basic variables are, C1 has a pivot, C1 is a pivot column, so x1, C2 is a pivot column, x2, C3 is also a pivot column, x3. All the three variables are basic variables. Then is there any free variable? No free variable. Now let us see in this case how will be the solution. So let us rewrite this echelon form as matrix equations again. So I have here these equations as 2x1 plus 4x2 plus 5x3 is equal to 4, minus 3x2 minus 6x3 is equal to minus 6, and 3x3 is equal to 6. So you have here three equations, three variables. So 3 implies I have x3 is 2. Then substituting in 2, I have minus 3x2 is equal to minus 6 plus 6 into x3, that is 2. So I have here it is 6, which implies x2 is minus 2. Then substitute these two values in 1, that is substituting in equation 1. So what do you have? 2x1 plus 4 into x2 is minus 2 plus 5 into x3 is 2 is equal to 4. On simplifying, I'll get the x1 value as 4 plus 8 minus 10. So this is 2x1, which is equal to 2, which implies x1 is equal to 1. So I have a solution that x1 is equal to 1, x2 is equal to minus 2, and x3 is equal to 2, which is a unique solution. Unique solution. There is no chance for this system to have another solution. And what do you observe here regarding basic variables and free variables? no free variable. So here you have to remember no free variable. Then, so till now I have obtained two things. That is, the first thing is, if there is a free variable, then the system has infinite solutions. And the second point is, no free variable implies it has unique solution. So infinite solutions, unique solutions. Now what about it has no solution, that is inconsistent system? How do you identify it? So I'll give you directly one example where I have an echelon form. So suppose I have a system of equations and which is reduced to matrix equation, and its echelon form AD, augmented matrix, and reduced to echelon form is in the form like this: 1 0 minus 5 1 0 1 1 4 is randomly I'm giving just some matrix. Suppose this is reduced to echelon form, suppose. Then mark the pivot, right? So I have here, I will mark only till here. This is pivot, right? Fine. But when I calculate, I have only three variables, that is C1, C2, C3. But when I talk about this, I will not take it as a pivot column to consider about the basic or free variables. But how do I decide now whether it has a solution or not? So before writing basic or free variables or anything, here also I have two pivot columns, means two basic variables. C3 is free variable, but I cannot just conclude that by that it has infinite solutions. So I'll write the equations: x1 minus 5x3 is equal to 1, then x2 plus x3 is equal to 4. Whereas the third row, if you observe, you have 0 is equal to 2. Is it possible? This is impossible, or you can say it is a contradiction. That means if you have, or if you obtain a row with all 0 entries, but in a non-zero entry in last column, that will give you a contradictory equation that 0 is equal to some constant k, which is not possible, a non-zero constant k. So why are you getting this contradiction? Because this system has no solution. So when any echelon form is given, that means after you reduce the system of equations to echelon form, so I got the echelon form, then what do I have to first check for? I have to check for, like, the first point, what I have to check for: a row with all zeros except last column entry non-zero. Then my answer will be, that is here 0 is equal to k. If you are getting this, then my answer is no solution. Then if it does not happen, that means, or if it does not happen, then you will be checking for no free variables. Then you will say unique solution and a free variable. A free variable means it can be 1 or 2 or more. Then infinite solutions. So in this way you can check whether a given system of equations has no solution, or it has unique solution, or it has infinite solution. Thank you.